Now, students, I entered into another program which is very frequently you face. When you are facing any interview, at that moment they ask you this question very frequently. Write a logic for extracting the number is a prime number or not. You check, entered a number and check it is a prime number or not. That question you very frequently face. So anyway, what is a prime number? The number divisible by itself and number is divisible by 1 is a prime number. So how can you write the logic for that? So how can you check the entered number is a prime number or not? So these are very simple programs, but when you started your career, at that time, these codes are very much required to understand. Now see, I just show you that is how the task is possible. I write here, there is a notepad. Yeah, you see, what I can do here, that is prime dot Java, or you can write here prime check dot Java, whatever you write. I want to check the number is a prime number or not. So what I can do here, import java dot util dot, that is scanner. I'm importing the scanner class. That is public class. What the class name is? That is prime check. Prime check is the class. What I can do here, public find static void main. Here you see, I just write here string args. I've just entered into the main. Fine. What's my next job? Is scanner s is equal to new scanner. What's I pass system dot in. Because I have to take the input from the keyboard and I want to check that number is a prime number or not. So what I can do here, I just write a system dot out dot println. Here I pass. There it is enter. Here you see enter a number. I just entered the number. Fine. What I can do here, enter num is equal to s dot next enter. You know that whatever the number I entered, that number is assigned to num. Now take an example, I entered a 5. You know that a 5 is a prime number because you know that a 5 is divisible by itself and it is also divisible by 1. So how can you calculate that? You have to use a counter. That counter check that is it is divisible by itself and divisible by 1 means it is a prime number. So you know that I write here int count is equal to 0. When inside the logic, if the count value is 2, then it is a prime number because you know that first time when it is divisible by 1, then it is count is equal to 1. When it is divisible by itself, the count is 2. So how can you write the logic? You just do one thing. What is my next job? I just write here for, I just write. There it is int I is equal to 1. I just declare the value of I is 1. Because I want to specify that the I values, that is what when it is divisible by 1 and divisible by itself, then it is a prime number. Fine. I started from 1 because I want to check is it divisible by 1 or not. Then I less than equal, that is num. Fine. Then I plus plus. Anyway, I enter into this part. So if the num value is 5, I starts from 1, then I continue up to 5. Then it check is it divisible by 1 and divisible by 5, then it is a prime number. It is not divisible by 2, it is not divisible by 3, it is not divisible by 4. Only divisible by 1 and only divisible by 5, then it is a prime number. What I can do here, if I just write here, that is, I write here, that is num modulo I, here you see, equals, that is, equals what? 0. What is the job of the modulo? Modulo means what? A remainder. If the remainder is 0, then fine. At what time the remainder of 5 is 0? When it is, I'm using I value is 1, and when I'm using the I value is 5, then it is the remainder is what? 0. Then here you write count plus plus. Here you see, what is my next job? That is fine. Here you see, that is the end of the loop. What is my next job? I write here, if that is count equals 2, then fine. What I can do here, system dot out dot println, that is num plus, that is a prime number. It is a prime. Else fine. What I did, system dot out dot println, what I pass here, num plus, that is not a prime number. Otherwise it is not a prime number. Is it over? That's the end of the block, end of this area. Check here. That is all about this concept. Now see here, when the logic starts, take an example, that is num value is 5 as per your word. I starts from 1 less than equal 5. Yes, 1 less than 5. Condition satisfied for the first time. If 5 modulo I value is 1, 5 modulo I, yes. Equals 0, yes. If it is 1, 5 modulo I equals 0, count plus plus. Count value is 0, 0 plus plus is 1. Now, after that, remove I plus plus. What is the value of I is 2? 2 less than 5, condition satisfied. If 5 modulo 2 equals 0, no. When it moved to second time, the condition not satisfied, then I plus plus. Out from the condition, I plus plus. I value is 3. 3 less than 5. Yes, condition satisfied. Move to here. 5 modulo 3. No, it is not equals 0. This condition not satisfied. I plus plus. I value is 4. 4 less than 5. Yes, the condition satisfied. But when you move here, 5 modulo 4 equals 0. No. Then I plus plus, I value is 5. 5 equals 5. Is the condition satisfied? Yes. 5 modulo 5 equals 0. Yes, condition satisfied. So count plus plus. What the value of count is? 2. Then 6. 6 less than equal 5. My condition not satisfied. What did I write? If count equals 2, yes, in case of 5, count value is 2. Then the condition satisfied. So num is word of 5. 5 is a prime number. Simple logic you have to use for this application. Very simple. I'm just writing the code like this. I use a loop. The loop starts from 1 less than equal num, whatever the number is, 13, 17, these are what the prime number. So remember, when the count value, that is what, when the condition satisfied, this condition satisfied how many times? 2 times. At what time? 1 is, it is modulo, that is 1 always equals 0, and itself, the number itself equals 0. In these 2 cases, the condition satisfied means it is a prime number. So this is the way you can think, and this is the logic you have to use. See, I just show you what actually happens. There is a Java C, there is a prime check, there is a prime check Java, there is a prime check. What I can do, I entered, there is a 5, see here. I entered a 6, is not a prime number. I entered a 7, is a prime number. I entered 8, not a prime number. I entered 9, 9 is not a prime number, because 9 divisible by 9 also, 3 also, 1 also. So here the count is 3. When the count is 2, then it is a prime number. So that's all about the concept of a prime number.